So if you're an architect juggling apps across AWS, Azure, and Google Cloud, you know the feeling, right? You deploy the exact same application, the same containers, but the performance you get is just all over the map. Well, today we're going to talk about how to get out of that mess. We're going to build a universal playbook for Kubernetes autoscaling that actually works everywhere.
All right, here's our game plan. First, we're going to really nail down the problem. Then we'll talk about the HPA, the tool that's supposed to handle this. After that, we'll dive into the real reason things get so messy, the cloud metrics maze. But don't worry, we'll then lay out a universal strategy to fix it and wrap it all up in an architect's playbook you can use right away.
Okay, let's just get right into it. The core problem. You've done everything right. You've architected for the cloud, but your multi-cloud setup still feels, well, broken. Why is scaling such a mess?
I mean, this is the question that keeps people up at night, isn't it? You've containerized your app, your Kubernetes configs are pristine, your environments are supposed to be identical. But the way your app scales on EKS looks totally different from how it behaves on AKS or GKE. What gives? And this, right here, this is that frustration visualized. On the left, that's the dream, right? Smooth, predictable scaling that just works. But on the right, that's the reality for so many of us. You get these crazy spikes on EKS, maybe a super slow response on AKS, and GKE is just doing its own weird thing. And look, this isn't just a minor headache. It directly impacts your users, your system's reliability, and frankly, your cloud bill. So let's talk about the hero of our story, or at least the one who's supposed to be the hero, the horizontal pod autoscaler, the HPA. At its heart, the HPA is a brilliant and simple idea. It just watches your resource metrics like CPU, and if things get too busy, it adds more pods. When things quiet down, it removes them. It's really the engine that powers elasticity in Kubernetes.
And that's the key phrase right there, in theory. The HPA config itself, the YAML you write, it's totally cloud agnostic. You write one set of rules and it should just work, no matter where you are. But, as we're finding out, theory and reality are two very different things in the multi-cloud universe.
And this brings us to the real villain of the story. Why does a perfectly good HPA configuration just fall apart across different clouds? The answer is what I like to call the cloud metrics maze.
I love this analogy because it just hits the nail on the head. Your HPA is the sheet music. It's one clear set of instructions. But each cloud provider, your EKS, your AKS, your GKE, they're like musicians who are all reading that music using their own weird measurement system. The result? It's not a symphony. It's just noise. It's chaos.
And here's the proof. This is what that chaos looks like under the hood. Your HPA isn't getting its data from one place. On AWS, it's listening to CloudWatch. Over on Azure, it's talking to Azure Monitor. On Google, it's plugged into GKE Cloud Monitoring. Each one of these has its own data formats, its own latency, its own APIs. They simply do not speak the same language at all. So what do you get? You get this. This chart pretty much says it all. You throw the same amount of traffic at your app, and EKS might be scaling way up, while AKS is just lagging way behind, and GPE is off doing something in the middle. You're stuck playing this endless, frustrating game of whack-a-mole, trying to tune each environment one by one.
Okay, so how do we escape this maze? How do we fix this? We have to get our orchestra in sync. And that means we need a universal tuning strategy. We need to create a common language for scaling that every cloud can understand.
And this right here is the big architectural shift in thinking. The answer isn't to get really good at tuning CloudWatch, and then Azure Monitor, and then GKE. That's a losing battle. The real pro move here is to build an abstraction layer for your metrics. And here's how we do it. In 3 pretty straightforward steps. First, you standardize. You pull in all those different cloud metrics into one place, like Prometheus, and you normalize them into a single format. Second, you expose. You set up a single custom metrics API that serves up these now standardized metrics. This becomes the only thing your clusters talk to for scaling. And finally, step 3, you unify. You point all of your HPAs across all clouds at this one single API. Now, it doesn't matter where the metric came from. The HPA sees one consistent, reliable source of truth. And the result? Oh, it's beautiful. Instead of that chaotic before chart, you get this, perfectly synchronized, totally predictable, and optimized scaling across every single cloud you're on. You tune it once, and it just works.
everywhere.
Okay, let's wrap all this up into an actionable playbook. These are the things you should be thinking about, like right now.
First, just accept it. Native cloud metrics are not the same. Just acknowledge that. Second, stop fighting that losing battle of tuning the HPA for each cloud. It's just not going to scale. Instead, and this is the most important part, abstract your metrics layer. Make a custom metrics API your one and only source of truth for the HPA. That right there, that is the path to predictable multi-cloud performance.
You know, when you implement this strategy, you're fundamentally changing your job description. You stop being a chaos coordinator just reacting to fires. You become the conductor. You're leading a finely tuned orchestra that performs perfectly no matter what stage you put it on.
And that leaves us with one last big question to chew on. We've laid out a really solid architectural pattern for today. But as AIOps platforms get smarter and smarter, is this whole metric abstraction strategy going to be the essential foundation that they all build on top of? Or will they just make it obsolete? It's definitely something to think about. Thanks so much for tuning in.